Hello everyone and welcome back. Let's quickly see how we can work with UUID in Java. UUID stands for Universally Unique Identifier or ID. It's a unique ID across time, machines, and systems. It's basically a 128-bit value. Uh, we use it for assigning IDs to entities or objects in our program. So to work with UUID in Java, we have a built-in class for that called UUID. Excuse me. This comes from java.util package. If we uh, click on this class, it's going to automatically import the package inside our project. Okay. Let me delete this very quickly. So we have the UUID class. If we go to its definition, I'm gonna press Control and click on the class name. Here we can see the documentation about the UUID class. Go ahead and read that. We see that UUID provides some attributes and also some static methods. Okay, we can call the static methods using the class name. For example, this is a static method. We can parse the UUID from a string or a API. If we read that, we can parse that and create an UUID object. So we have the class name. Let's press dot and we can see the static methods. One of the static method is random UUID. This is a method. We can see here it's a method and it returns a UUID type. Let's call this one, and this method returns a UUID. We can store it in a variable of type UUID. Let's call it my UUID equal to UUID dot random. It's going to randomly generate a UUID. We can print that as out my UUID. It's going to generate every time a randomly unique ID. Okay, create that. We get another UUID. Run it. We get another UUID. So if I want to like generate 10 unique IDs, I can write a for loop for that. For I want to generate 10 times, and I can put this line of code inside the for loop. This way we can generate UUIDs for our objects in our project. We can also parse UUIDs from a string. Let me copy these. If UUIDs are given as a string for us, we can parse that. Let me just paste it here for the moment. I'm gonna take one of this UUID. Say we are reading this UUID from maybe from an API, or we get it from a file or whatever. For now, let's store it in a string, a UUID string version, and I want to put it here. We don't want to have a new line and we don't want to have a space. So if we have a UUID like that, we can create a UUID out of this, a UUID object, by calling the classes static method. The other method we have from a string, it accepts a string and returns a UUID object, right? So let's call this function, and I want to pass UUID string. This is going to return an object of type UUID. I can store it my let's call it new UUID equal to UUID dot from string. Okay, I'm gonna comment out these lines of code and let's run it. We can print the UUID, my new UUID. I can print that. Let's change a value. Let's say I want to change this to maybe a W. Let's see, is it a valid UUID or not? If it is not a valid UUID, we might get an exception and we cannot parse that. See, it's not a valid UUID and we got a number format exception, error at index 11. In this part, we got an error and we change this value. Okay. And if I want to add some more values, this is also not a 164-bit, I believe 128-bit. This is also an invalid UUID. We cannot parse it and make an UUID object out of that. If I run it, we get another exception. Illegal argument exception, UUID string is too large. Okay. Let's have a quick exercise. If we are given a file, let me quickly create a file here. I believe, let me get it from internet maybe or somewhere. If we have a CSV file, for example, maybe this small CSV file, I'm gonna copy and create a CSV file. I'm gonna create, not that one, create a file in the root directory of my project. Well, let's call it transactions.csv. It's a comma separated value or file. I'm gonna paste it here. So we have some UUIDs here. Let's say if we can read this file and parse this UUID as an object, and I believe we have account holder and transaction account holder here. Maybe this is account type, transaction type, account number, and what else we got? We got this 1, 2, 3, 4 pieces of information about this transaction. So this line is a header line. I'm gonna put a hash behind that to comment it out. So when we read this information from the file, I want to ignore this. Any line that starts with a hash value, I know it's a comment or metadata about my file, so I don't want to read that. So the real data starts with a UUID. Okay, let's quickly read this information. We can create a class for that. We have three types of transaction. We have deposit or either withdraw or transfer. Okay, can we create a class for that to model this? Yeah, we can do that. Let's create a transaction class. Transaction. I'm gonna call it transaction. What we have here, I'm gonna put it here side by side so I can have take a look at that. Let's say what I got. I got private. I'm gonna put everything as private. Private. I have UUID. Let's call it ID maybe. Then I have private account number. Private int account number. What else I got? Private string account holder. That's the name of the person. We define it as a string. Account holder. What else we got? We got private and transaction type. I can put it as a string. Transaction type. But since we know that we are going to have only three types of transaction and these are constant values, a good practice would be to create maybe an enum for that. If we put it as a string, we can have any type of value for that, right? This string can hold any value as a string. Transaction, maybe deposit, withdraw, transfer, and more values. To restrict that, since we have three constant, we have closed set of transaction types, and we don't want to accept any other value other than these three values. How can we do that? We can create an enum for that. And instead of defining it as a string can hold any value. We want to limit that to a group of predefined constant values, right? We have group of three values, constant values. So it's a good practice to, instead of storing it in a string, we can store that in an enum. Let's quickly create an enum for that. So instead of creating a class, this time I want to create an enum. Let's call it transaction type maybe. And we have these values, right? These constant values. So I'm going to copy that. And we know when we define a constant, the convention is that we put the constant variable names or the names, constant names as uppercase. So I'm going to put deposit here, withdraw, and transfer. So we cannot store any other value other than these three. We cannot have any other type of transaction other than these three type of transaction. So enums gives us a type safety, right? And now our type is safe. We cannot hold any other value other than these three. So let's go to our transaction definition. Instead of a string, what I can do, I will define private transaction type. We got a type for that, an enum type. Let's call it transaction type. Okay, we got that. Let's define the constructor. Press Alt Insert. I wanna first of all have the no argument constructor. I select none. Then I wanna press Alt Insert again. Constructor. I wanna define the constructor for everything. Let me close this very quick so that we can see everything. I got the constructors. Let's quickly define the getters and setters for our class. I can go create getters and setters for everything. Press Shift and down arrow to select everything. So we got the getters and setter for our class. And finally, I'm gonna just have the toString also, just in case. Okay, just in case if we want to print that, we can change this toString the way we want to have a string representation of our object. So now we have the object or the class or the blueprint to model these data from our file. What was our file? We created transaction.csv. We can start reading this and change this UUID, create an object out of that, parse this value to an integer value maybe, or long value, or let's have this one. Let's see if we can hold this account number in an integer. If not, we can change it to a long value. Okay, so inside main, what I can do is I'm gonna get rid of everything from here. What I'm gonna do is I will start reading from the file. We can use a scanner for that, or file reader. Let's use a scanner. I'll create a scanner equal to new scanner. Create a scanner object. This scanner accepts resources from where we want to read the data. We have different stream for that. For example, we have keyboard stream. If you want to read from the keyboard, we can say system.n. Or if we want to read from a file, we can create a file for that. New, let's create a file. That file comes from java.io. We can create a file. If I press Ctrl P, a file constructor can accept a path name, string path name, and all other URI. Maybe we can pass a URI. Let's pass a file path or path name. Since our file is in our root directory, I can just copy the name and just paste it over there. I don't have to provide the maybe relative or absolute path for the file. So the scanner, when reading a file, it might throw an exception. We have unhandled exception. Maybe a file not exception might be thrown if the file doesn't exist. So we're gonna either put it in a try catch block or just let's just surround it with a try catch block. So we are trying to read the file. If the file doesn't exist, we throw an exception. Let me quickly run the project and see if we are able to. Yeah, we could successfully open the file, I believe, and we can now read the file. Okay, I can say scanner dot maybe next line is going to read each line, right? And it will return, I believe, a string. I can hold it in a variable. Let's call it line. So I read line by line, and I will say while I keep reading until I reach end of the file. And scanner has another method, y scanner dot has next. It returns a boolean. While there's line is still in the file, I keep reading that. Okay, I'm gonna put this line inside the while loop, so we keep reading until we reach end of the line. We might have some metadata about our file. We know that metadata or comment starts with a hash. Any line that starts with a hash, we want to just ignore that. So if I go to main method, I just want to, let's see, print the line and see if we are able to read everything from the line, from the file. Yeah, we can read everything from the file. We got the data, and I don't want to read this line. Okay, maybe if we have more comments or metadata about our file here, if I have something here, this is maybe another line. or metadata, whatever. So I don't want to read these. These are not the real data. We are not interested in these lines. How can we ignore that? If I run right now, everything is red, right? So since this is a string, once I read the line, I will check if line, this is a string, we have a function for that, start with. If the line starts with a hash code, I just want to ignore that and I will continue reading, okay? I don't want to execute these lines of code below, but I want to continue. Let's run that. Now we skipped reading these two lines and we read the real data. Now we got the real data, we got it as a string, and we know that each piece of data is separated by a comma. We can extract this data. We can split the line of code based on the splitter or the comma. So here, instead of maybe printing the line, I can say line. We have a split function that takes a regular expression based on what we want to split the line. We want to split the line based on the comma. I believe it's going to return a string array, the split function, yeah, a string array, and we can catch it to a string array. Let's define a string array. Let's call it maybe data. We got the pieces of the data, and if I want to print the data, since it's an array, either I can loop through that or I can use this a built-in function or utility function, arrays.toString, that takes an object, a string object, or an array object, and change it to a string. Okay, let's pass our data and let's print that. So now we splitted our data. We got the UUID at index 0, we got the account number at index 1, we got the account holder at index 2, and index 3 we got the transaction type. What we can do now, we can create an object out of these data, right? Let's create a transaction. Let's call it transaction equal to new transaction, right? And if I press Control P here, we can see the transaction accepts a UUID. It accepts an integer account number, a string account holder, transaction type, right? So let's extract the data. First, I will create a UUID. Let's call it ID, or maybe UUID equal to UUID dot maybe from a string. We got the string now. A string is located at 0 index of the data, so we can pass that, right? Data of 0. We created a UUID out of that. And then let's create account number of type integer and account number maybe equal to data of 1. So it returns a string. We can parse that to an integer using the integer.parseInt. We can use the wrapper class of integer to parse a string to integer, right? So at the data of maybe 2, we got what? We got the account holder. It's of type string. We can directly store it in a string variable. Let's call it account holder equal to data of 2. And for data of 3, third index, we got the what? We got the account, the transaction type. Either it's gonna be deposit, withdraw, and transfer, right? For that, we have an enum for that. Let's call it transaction type equal to this is a string. Maybe we have transaction type dot value of, right? It takes a string and returns a transaction type. Since by default every enum inherits from, I believe, enum, a built-in enum. We have it in java.util or somewhere. Let me quickly check that for you. If I say enum Yeah, we have an enum from java.lang. So by default, every enumeration we create or every enum we create inherits from this built-in enum. The same way as all the classes in Java inherits from the object class, so all enumeration inherits by default from enum. Okay, that comes from java.lang. That's why we got this value of that method that's inherited by the from the enum that's in java.util. Okay, so we got our data. We are gonna create our transaction. If I press Ctrl P, I can pass the UUID. We got the UUID from our file. What else we got? We got the account number. Let's pass the account number. And what else we got? We got account holder. Let's pass the account holder. And we got transaction type, right? So we have our object. We successfully, let's run it very quickly, see if we successfully read everything. Number, format exception, input is string. Where is that? Main Java here. I believe we are not able to store that in integer since it's long number. We have to define maybe a long for that. What I'm gonna do here, maybe for account holder, yeah, if I put it long here, let's see what happens. Long, and so we are going to return a long here. We are going to accept a long. And what else we need to do? I think everything should be the same. And if I come here in main, now instead of integer, let's try long. Oh, not parse. I want to define a long here, but parse long, right? Parse long. So here in the transaction constructor, we need to define not int and long here. I believe still we got an error. Let's see what the error is. When we run the project, now we successfully could read because that account number doesn't fit in an integer type. Okay, we defined a larger type for that. If I go here, maybe I can store them in a list. Let's define a list of transactions. List transaction, let's call it transactions equal to new array list, and we can create an object of that, and let's add all the objects to the transactions list. We have transactions dot add of transaction. Okay, so we add it here, and finally we can do anything we want with the list of transaction. Let's say I just want to print them out of the for loop inside the main. I have try here. Out of the try catch, here I can say like for maybe for transaction in the list of transactions, I just want to print them. It's out transaction. Let's see, we got all the transactions. We read it from the file, we parse the UUID, and we could see we saw how we can parse the other values. Okay, so thank you for watching and see you. Bye.